Thank you, Lana. Hi, everyone. My name is Matthias. I am Head of SRE and Automation at GitHub. I'm really happy to be here today talking at CloudOps, sharing some experiences and learnings we have gone through over the last few years at GitHub. So let me tell you about GitHub. GitHub is a UK-based MVNO that was founded in 2009. GitHub has some differentiators that is worth mentioning. First of all, GitHub doesn't do contracts, and that's because we want to give to our members the maximum flexibility and freedom when it comes to choose GitHub. GitHub is a digital-first business with very little presence in the high streets, and this makes very critical and important the role of our website and our community, as is the way we interact with our members. And finally, GitHub has members at its heart. So members are really important for GitHub. We got a very big and active community where members help each other, but they don't just help each other. They also help us making GitHub better, giving us feedback about the things that they like more or they like less about our website, about the functionalities we offer to them. And what we do is we work with members trying to make our website better, absorbing that feedback or getting that feedback that is invaluable for us and try to make it a reality. A lot of the functionality you can see on the website today was born from member ideas, and it's very common to see members in our offices. We've got a lot of initiatives with them so that we can get that feedback into GitHub. So based on this, one of the goals we always have had at GitHub was to bring members into our development lifecycle. So a few years back, our engineering teams used to work in a 2-week sprint cycle, meaning that we used to release code every 2 weeks. That gave us 26 opportunities over the year to go through this feedback loop and put new functionality to the members. Out of those 26 releases, not all of them were successful, and not all of them came with new functionality. So we felt we didn't have confidence in our ability to deliver due to the high rate of failure releases, and that we had to do something about it if we wanted to improve the continuous feedback loop with our members. So we came out with smaller goals, and we came out with a list of 4 goals. So first of all, we wanted to have the ability to release daily. This meant that we could release incrementally small chunks of code rather than doing changes every 2 weeks, big changes every 2 weeks. We wanted to remove manual intervention. We wanted our engineers to spend less time doing manual work, doing releases, and spend more time doing things that matter for the business. At this time, releases were manual, and they consist in a group of 4 to 5 engineers coming early in the morning to the office to release the code, test, and make sure everything was correctly and was fine, and making sure that we didn't have any impact for our members. We wanted to improve the quality of service that we offer to our members, meaning that we didn't have any kind of downtime or any impact in our services for our members. And we hope that all of this will improve the continuous feedback loop we are talking about. To achieve these goals, we decided to break the monolith. So we knew that microservices will help us achieving our goals. We know the benefits of microservices. They are highly maintainable and testable. They are loosely coupled with other services. They're independently deployable, and they're capable of being developed by small teams. So all these things will contribute and help into achieving our goals. However, what we don't hear that much talk about is about the downsides of microservices. When you go to a microservice architecture, the communication, you got much more communication between services, and communication between services is complex. You have a lot of calls over the network, and debugging issues or errors over the network is much more difficult than debugging software issues. And as an engineer, you need to make sure that your application implements things like circuit breakers or auto retries to deal with those network errors. On top of that, when you start breaking your application into microservices, means that now, rather than having to deploy 2 to 3 services plus database changes, you need to deploy all these new microservices. And we were doing this manually. So we have some deployment challenges as well that came out of microservices. So coming back to our goals, microservices, do they help us achieving our goals? Well, we were far away from releasing daily. We stood with the 2-week release cycle that we had in the past. We didn't remove any manual intervention. In any case, we made it work because we had now to deploy many more services, many more microservices. Releases were taking longer, so manual intervention actually increased. We did improve our quality of service, and we did improve the continuous feedback loop we were hoping to. So microservices are not a silver bullet if you don't have the right tooling around it to support them. So at this point, we decided to invest heavily into automation. We decided to make fundamental changes in our infrastructure and in our application to make this work. So first of all, we decided to migrate from our on-premise data center to cloud, and the cloud provider we chose was AWS. So migrating to AWS came with fundamental benefits for our goals. One of the biggest benefit was the ability to provision infrastructure ourselves and through code. So programmatically, meaning that our infrastructure was immutable, was easily reproducible. So we want to move away from long-lived hardware and move into short-lived hardware. This was a step forward for us. And our lead time to provision infrastructure was reduced massively. We went from weeks to provision servers to minutes. And we cut down the intermediates to get this done, right? We could interact directly with the AWS API to provision your hardware or servers. AWS also make it easy to run those services that are not a differentiator for your business. And I'm referring to things like databases, cache systems, or stream services. So these managed services reduce the overhead in our teams. Maintaining, patching, and upgrading these services become much easier than you have to do it yourself. So the next decision we took was to run our services as containers, as Docker containers. And this was really important because containers increase portability, and this is what we wanted our infrastructure to be short-lived, and this was really important for us. We wanted to make sure that the applications will run correctly, regardless of the underlying hardware they were running into. And containers have another benefits like greater efficiency, etc. And finally, we wanted to run our containers in a container orchestrator. And for that, we chose OpenShift. A container orchestrator helps improving our quality of services because it comes with a set of functionalities that out of the box help with that. And I'm referring to functionalities like self-healing or auto-healing, like autoscaling through horizontal pod autoscaling, or automated rollbacks in case your health checks doesn't pass. Why did we choose OpenShift? Where there was a managed service Kubernetes offered by AWS at that time, and we didn't have much experience either running containers or running a container orchestrator or maintaining a container orchestrator or supporting a container orchestrator ourselves. OpenShift offered us a level of support that we wanted or that we needed at that moment, because that meant that we have someone that we could call in case something were to go wrong. And we successfully ran our services in OpenShift for about a year. until we start to face some issues. This OpenShift cluster was provisioned by ourselves. It was running on EC2 instances in AWS, and we manage all the installation and all the lifecycle, patching, upgrading, etc. And there is when we start facing some challenges, right? The application scalability is something that we sort out through Kubernetes features. I talk about it with horizontal pod scaling, and based on some metrics coming from Prometheus, we were able to scale our application horizontally. However, scaling up and down the OpenShift cluster was much more difficult because that meant that we have to manually provision new EC2 instances and then run a bunch of Ansible scripts to make those instances part of the cluster. So for the cluster to recognize those new nodes as part of it. This was very tedious and was very difficult, and it came with a lot of operational overhead. We had to manage both control plane and data plane, and upgrading. Things like upgrades were really painful and used to take us weeks. Again, we were falling back again to long-lived infrastructure because we were treating these OpenShift nodes as long-lived servers, and it's something we want to get away of we didn't want this because we suffer of this problem in the past. So we start thinking about moving to a vanilla Kubernetes because we knew that the process of maintaining the cluster, upgrading the cluster was much more simple than with OpenShift. And at that time, AWS came with EKS, their flavor of managed service Kubernetes. So we gave it a go, and we start migrating our workflows into our workloads into EKS. So moving to EKS, we move part of the operational overhead as the control plane part of your cluster is now managed by AWS. Scaling the cluster and adding new nodes to your data plane is much simple, although it was still a manual process, right? So we didn't fully solve scalability issues as the cluster still need to be updated or scaled up and down manually. And that meant that most part of the time we ended up either over-allocating or under-allocating due to the variety of workloads we were running in our cluster. To solve this problem, we started looking at with the scalar solutions, and we came across spotting, right? So what spotting does for us, or Spot, is adjusting the amount of computing needed by our applications when they scale up and down due to the workload, and it guarantees that our cluster always has space to allocate our applications, and it does this in a very efficient way. As the cluster runs in the AWS spot market, meaning that you get the cost benefit of it. Spot has helped us a lot with our delivery lifecycle, as there is no wait time to provision new resources or new capacity to run our applications, meaning that reduces the friction between developers and operators. Developers don't need to wait anymore to get the capacity they need to run their applications. It has drastically removed manual intervention, and scalability has improved, as now the data plane changes constantly, adjusting dynamically to our workloads as needed. And it's very cost efficient, as I said. It's running in Spotting and has reduced our costs about 70%. So right from the beginning, we have been running EKS in 100% Spot instance, falling back to on-demand instances if required, because the market, for example, you don't find a Spot instance in the market at the time you need it. Over a period of 24 hours, our cluster scales up and down a lot, as you can see in the image, and meaning that these instances are short-lived instances. They are recycled pretty much every week. And obviously, this reduces the maintenance and increases the level of confidence in your infrastructure. And the resource allocation, as I said, is really good. We have a 5% headroom scheduling in or configuring in EKS. And as you can see, our cluster is all the time running pretty close to that limit. Right, so coming back to our initial goals, have we achieved our goals through automation in our journey? So yes, we have. So the first goal was to release daily, and we have massively achieved this goal. We have gone from daily releases to continuous deployment, meaning that we end up 2020 with more than 9,000 releases or deployments across all of our services. All of these deployments were done or are done automatically through a CI/CD pipeline, meaning that manual intervention was completely removed. The quality of service was increased. As I mentioned, just by the fact of running a container orchestrator will help you improving your quality of service, will help you reducing downtime or etc. And obviously our continuous feedback loop with our members has increased dramatically. We can put features out to them daily, multiple times a day, gather feedback and iterate over it. On top of that, we're running a platform that is 70% cheaper than what they used to be. So cost efficiency is another quick win. And that's it. Thank you for listening. And if you have any questions, I'll be looking at the chat. So I got some questions coming. First question is, how are you handling upgrading your infrastructure and doing things like rolling and blue-green upgrades? Well, as I mentioned before, our infrastructure gets recycled very often. Instances are short-lived, which give us a lot of confidence in our kit. Upgrading, if you're referring to upgrading, for example, our Kubernetes cluster, we do upgrade the control plane through our pipeline, and then we kick off a rolling upgrade through Spot in our data plane. Spot manages all the workloads, meaning that it moves the workloads to new instances and decommissions all instances without any type of downtime in the application, which is great. So upgrades are much more simple and easy. Regarding blue-green upgrades, we are using or we are looking at using other tools like Service Mesh in conjunction with Flagger to achieve this goal. My question: are you able to use multiple instance types and sizes and different availability zones? So yes, we use a variety of EC2 instance types. We try to give as many instance types as possible for Spot to choose, because that means that it's easier to get an EC2 instance in the Spot market when you give more options to Spot. And also this due to the different type of workloads we run. Some are more batch intensive for an hour and need maybe more CPU, and others need more memory. So Spot will choose the right type of instance. Regarding the availability zones, we use affinity rules in our application so that different copies of our application run in different availability zones, and Spotting will make sure that you got the right instance in the right availability zone at the right time. How has using Spot instances impacted the way you build your applications? Well, it has speed up our whole delivery cycle up. As I said before, it makes it possible to increase the feedback loop, as I mentioned in the previous presentation, and it allows engineers to get their applications out to production without manual intervention and without any friction, without any dependency in the operators. So it has been good improvement in terms of the of progress building our applications. I think that's it. Thank you very much for listening.